It's totally unstable. It's going to explode. No, giving me is not going to be an amazing chance to go for that. The thing is, it might be tomorrow. It very well might be during this transmission, and it would shimmer like a subsequent sun above the James Webb Telescope. Recently, it has identified a surprising 250% extension in the brightness of Creepy Crawly Jew, the red star located at the shoulder of the Orion constellation. This flighty behavior has ignited excitement for a fascinating showcase. Some suggest the unexpected increase in brightness could indicate that Betelgeuse is preparing to go supernova, but the specific timing remains uncertain. Experts estimate it could happen soon. Join us as we explore the depths of space and unravel the mysteries surrounding this divine giant. Betelgeuse has the potential to reshape how we understand the universe. Despite its name not being widely known, you've likely admired its brilliance. A bright reddish glow radiating at the shoulder of Orion, a prominent star cluster. Betelgeuse's size is staggering. If placed at the center of our solar system, its outer surface would extend past Jupiter's orbit. This monster star, easily visible, continues to captivate us. Unlike most stars, Betelgeuse fluctuates in brightness over time due to its proximity to our system. Known as a semi-regular variable star, its brilliance changes periodically, hinting at a possible catastrophic collapse in a cosmic explosion. Recently, Betelgeuse has become even more captivating due to dramatic fluctuations in brightness. These fluctuations include a major surge on May 20, 2023, when scientists noticed an astounding 142% increase in brightness, followed by a later update showing a 150% increase. Andrea Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse now ranks as the 7th brightest star in the night sky, moving up 3 spots from its usual 10th place. From the southern hemisphere, Betelgeuse shines brightly in the evening sky, easily visible at the shoulder of the Orion constellation. Dr. Sarah Webb, an astrophysicist from Swinburne University of Technology in Australia, emphasizes Betelgeuse's importance. It offers an intriguing opportunity to study the final stages of a massive star's life, providing critical insights into the behavior of red giants before they explode as supernovae. When Betelgeuse eventually explodes, it could become incredibly bright for about a week, potentially casting shadows at night. This prospect has both amateur stargazers and professional astronomers eagerly awaiting the event. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Padaro Space Experts and Cosmology Club, highlights the enduring interest in Betelgeuse's brightness changes, a phenomenon long unnoticed by various cultures. Currently, Betelgeuse's brightness cycle lasts around 130 days, significantly shorter than its usual 400-day cycle. These rapid changes give astronomers a unique opportunity to study this celestial anomaly in detail, revealing more about the final phases of a star's life. The unusual behavior of Betelgeuse began in 2019 when it violently ejected part of its outer atmosphere. These fluctuations in brightness are uncommon for Betelgeuse, sparking speculation about whether it will soon explode into a supernova. According to a paper by Dupree and other scientists from Harvard and the University of California, Berkeley, it will take another 5 to 10 years before Betelgeuse returns to its normal 400-day brightness cycle, as its light and outward speed behavior have changed. Despite its erratic behavior, Betelgeuse remains a massive red supergiant star, going through the final stages of rapid development as it depletes its fuel. The core will eventually collapse under its immense mass, resulting in a cosmic explosion that could potentially obscure entire galaxies. The timing of this explosion remains uncertain, as explained by Dr. Doc, a professor of cosmology at the University of Portsmouth. Predicting cosmic explosion events is challenging due to the limited historical data and the complexity of stellar evolution. Betelgeuse is currently undergoing fusion processes, constantly evolving through elements like helium, carbon, oxygen, silicon, and iron. As a red giant star, it fuses helium into carbon at its core, a process that takes millions of years. Eventually, it will advance to fuse heavier elements until it can no longer support fusion reactions, leading to gravitational collapse and possibly forming a black hole or neutron star. While some speculate about Betelgeuse's impending explosion, Historical records indicate that it has been becoming redder over the past 2,000 years, suggesting that it may take considerable time before it goes supernova. NASA estimates that Betelgeuse isn't expected to explode for another 100,000 years, offering comfort that its explosion is unlikely to occur within our lifetimes. Despite the uncertainties in Betelgeuse's behavior, its fluctuations continue to captivate scientists and inspire advancements in our understanding of stellar evolution. Dr. Sarah Webb reminds us to remain open to all possibilities, even as we acknowledge that the likelihood of witnessing Betelgeuse's explosion in our lifetimes is slim. Monitoring its changes may lead to further scientific breakthroughs, encouraging us to keep hope alive for new discoveries in the universe. It's important to remember that our observations of Betelgeuse are essentially glimpses into the past. The light we see from the star is over 600 years old, meaning Betelgeuse may have already exploded, and we wouldn't yet know about it. While this possibility exists, it remains uncertain. History has shown that our assumptions in space science can be challenged. Before 1987, astronomers believed only red supergiants could go supernova. However, in that year, a massive blue star in another galaxy exploded, astonishing the intellectual community. There is still much to learn, and surprises may lie ahead. Observing Betelgeuse and other massive stars allows us to expand our understanding of stellar phenomena. Regardless of the lack of an impending explosion, Betelgeuse's ongoing behavior remains captivating. Its fluctuations between dimming and brightening reveal fascinating physics. The fact that stars pulse on human timescales is extraordinary. While Betelgeuse is currently much brighter than expected based on its typical multi-day cycle, there is hope it will eventually return to this cycle. However, later observations suggest that Betelgeuse may be in its late stages, transitioning toward the end of its core carbon-burning cycle. This stage involves the transformation of carbon into heavier elements like oxygen and magnesium. If this is the case, scientists anticipate a core collapse leading to a supernova that could occur within a few years. Nonetheless, the exact stage of Betelgeuse's evolution remains difficult to determine, and uncertainties persist. The possibility of witnessing Betelgeuse's explosion remains unclear, as the carbon-burning stage can last up to 1,000 years, and the study suggesting an imminent blast has yet to be accepted for publication. Nevertheless, the potential for Betelgeuse to become a supernova is thrilling. It would be an exceptional event, visible even during the day for several days when the explosion finally happens. The early signs of the cosmic explosion will be subtle but undeniable, with neutrinos sweeping across Earth as high-energy photons escape from the expanding cloud of stellar debris. Betelgeuse will gradually grow brighter in the night sky, possibly reaching peak brilliance 10,000 to 100,000 times its normal brightness within only a few weeks. This spectacle will astonish anyone fortunate enough to witness it, marking a critical moment in cosmic history. The remnants of Betelgeuse's explosion could be as bright as a quarter or half of a full moon packed into a single point of light. Incredibly, this brilliance would be visible during the daytime, creating dramatic shadows at night. Forecasts suggest that Betelgeuse may become 15 to 100 times brighter than Venus, currently the second brightest object in the night sky. The display of Betelgeuse's explosion would last for around 100 days, captivating space enthusiasts and offering a unique opportunity to observe the aftermath up close. Fortunately, Betelgeuse's supernova would pose no threat to humanity, as it is still far away. Telescopes and optical instruments would allow us to observe the event without harm. Nevertheless, such a sensational event would not go unnoticed. Supernovae are often interpreted as ominous signs, and Betelgeuse's death could provoke fascinating responses worldwide. Astronomers believe it could even reignite widespread interest in stargazing, awakening people to the wonders of the universe. Betelgeuse is not the only red supergiant in our galaxy. Others, like Edi Carinae, could detonate before it does. In fact, our Milky Way should witness a supernova roughly every 100 years, but we haven't seen one in the last 400 years. Nonetheless, we've observed the remnants of past explosions, indicating that we are overdue for a significant cosmic event. It's only a matter of time before the next star puts on its monumental act for the universe to observe. Betelgeuse's history is rich with notable events, including the dramatic dimming in the fall of 2019. This sudden decrease in brightness confused cosmologists and sparked speculation about its potential explosion. Although Betelgeuse's brightness returned to normal by April 2020, the cause of its dimming remained a mystery until further observations provided insights into the phenomenon. Skywatchers can easily spot Betelgeuse from their homes, making it an accessible cosmic entity to engage with. If a supernova occurs, it would undoubtedly provide an incredible celestial performance. As we continue to monitor Betelgeuse, the star remains a beacon of intrigue for both professional astronomers and amateur skywatchers alike. The ongoing changes in its brightness offer rare opportunities to study the processes occurring inside a dying star. With advanced technology, scientists can now analyze Betelgeuse's behavior with unprecedented precision. Instruments like the James Webb Space Telescope, alongside ground-based observatories, are helping unlock more secrets about this stellar giant. The study of supernovae, like the one that Betelgeuse may eventually become, has far-reaching implications beyond understanding the final stages of a star's life. These explosions play a critical role in the formation of elements heavier than iron, which are essential for the creation of planets, life, and the very universe we live in. In many ways, the death of stars like Betelgeuse contributes to the building blocks of the cosmos, enabling new stars and planets to form from the remnants of their exploded cores. Should Betelgeuse go supernova during our lifetimes, it would offer a unique and stunning opportunity to witness such an event up close. For those fortunate enough to observe it, it would be a once-in-a-lifetime spectacle. The light from the explosion would briefly outshine all other stars, becoming a prominent fixture in our sky. As astronomers race to capture the data, the event would fuel further advances in space exploration, encouraging more research into stellar evolution, cosmic explosions, and the mysteries of the universe. Regardless of when it happens, Betelgeuse's eventual explosion will be a critical event for astrophysics, expanding our understanding of star death and the life cycles of massive stars. The spectacle may also inspire future generations of astronomers, fueling curiosity about the universe and encouraging people to look up and wonder at the vast cosmos. As scientists continue to monitor Betelgeuse's behavior, the mysteries surrounding its life cycle and impending explosion continue to spark curiosity across the scientific community. One of the most fascinating aspects of this star is its unpredictability. While many stars exhibit regular patterns of brightness, Betelgeuse is anything but typical. The fluctuations in its light output are not only due to its natural variability but also the violent activity occurring in its outer layers. These eruptions, which eject material from the star's surface, are a hallmark of its instability and add an extra layer of intrigue to its potential for becoming a supernova. Betelgeuse's massive size and unusual characteristics make it an ideal candidate for researchers studying the final stages of a massive star's life. As a red supergiant, Betelgeuse has already exhausted much of the hydrogen in its core, leaving it to burn heavier elements like helium. This process results in the star expanding to an enormous size and becoming extremely luminous. However, once a star reaches this stage, it faces a ticking clock. As it runs out of fuel, it will no longer be able to support its own weight, and the core will collapse under the immense gravitational pressure, triggering a supernova explosion. Understanding this process is critical to astrophysics, as it provides key insights into the evolution of stars and the forces at play when they reach the end of their life. In addition to studying the physical processes leading up to a supernova, scientists are also keen on understanding the role stars like Betelgeuse play in enriching the universe with heavy elements. Supernovae are responsible for synthesizing elements like gold, platinum, and uranium, elements that are vital for the formation of planets and life. These elements are scattered across space when a star explodes, seeding the next generation of stars, planets, and possibly even life. In this way, the death of stars like Betelgeuse is crucial for the creation of the material necessary for the continuation of the cosmic cycle. The study of these explosions not only helps us understand stellar evolution, but also how the universe continually transforms and evolves. Astronomers have also turned their attention to the broader implications of observing a nearby supernova event, such as the one that could result from Betelgeuse's death. While such an event would not pose a direct threat to life on Earth, the scientific data gathered from it would be invaluable. The detection of neutrinos, for example, could provide new insights into the fundamental processes occurring inside stars during their final moments. Neutrinos are elusive subatomic particles that interact very weakly with matter, making them difficult to detect. However, when a star goes supernova, it releases a huge burst of neutrinos. Studying these particles could provide critical information about the physics of stellar collapse and help refine our understanding of the universe's most powerful events. Moreover, the visibility of a supernova in our night sky would undoubtedly captivate the imagination of people around the world. A supernova as bright as Betelgeuse's would be visible even during the day, offering a spectacle unlike anything most people have ever seen. It would serve as a reminder of the vastness and dynamism of the universe, prompting questions about the nature of stars, the fate of our solar system, and the possibility of life elsewhere in the cosmos. The emotional and cultural impact of such an event could be profound, fostering a renewed sense of wonder and appreciation for the universe. While the potential explosion of Betelgeuse is an exciting prospect, it is also a reminder of how much we still have to learn about the cosmos. Despite the incredible advancements in astronomy and technology, there remain countless unanswered questions about the life cycle of stars, the mechanics of supernovae, and the long-term impact of these cosmic events on our galaxy. Observing Betelgeuse and other similar stars allows us to refine our theories and continue pushing the boundaries of our knowledge. With the aid of advanced telescopes, like the James Webb Space Telescope and ground-based observatories, astronomers are uncovering new layers of understanding, mapping the evolution of massive stars in real time, and predicting the outcomes of cosmic events with increasing precision. Betelgeuse's eventual explosion, when it happens, will be one of the most studied events in modern astronomy. Its brightness and proximity to Earth make it a prime candidate for research that could yield critical breakthroughs in understanding the life cycle of stars. Whether we see the explosion in our lifetimes or not, it is certain that Betelgeuse will continue to captivate both professional astronomers and amateur stargazers alike for many years to come. It serves as a cosmic reminder of the transient nature of stars, the ongoing process of creation and destruction in the universe, and the boundless curiosity that drives humanity to reach for the stars.